9, 8,
The clock is
7,
operating. We're underway.
Tranquility Base here.
Endeavor, go at throttle.
Coming up on Destination Tomorrow, discover a new type of rover that may soon explore the Red Planet. Plus, learn about a robot that will assist astronauts in space. And our own Johnny Alonso finds out how telescopes work. All this and more next on Destination Tomorrow.
Hello everyone, I'm Steele McGonigal.
And I'm Kara O'Brien. Welcome to Destination Tomorrow.
This program will uncover how past, present, and future research is creating today's knowledge to answer the questions and solve the challenges of tomorrow.
In recent years, there has been renewed public interest in the planet Mars. This increased awareness is due in large part to the success of the NASA rovers, which have been used to explore and unlock the mysteries of the Red Planet.
Although wheeled rovers and stationary landers have been successful, it's becoming apparent that more of the Martian surface needs to be explored to provide a better understanding of the chemistry of the surface and the atmosphere. Understanding these conditions will help prepare scientists and astronauts for future manned missions to Mars.
One idea now being studied for future Mars trips is a very simple but revolutionary type of rover called the Mars Tumbleweed. This ingenious new rover will not use engines, but will travel across the Martian surface with the help of the wind. I had the opportunity to speak with Jeff Antal at NASA Langley Research Center to find out more. For thousands of years, the planet Mars has triggered something in the human imagination. Generations of dreamers and scientists developed scientific theories about what they believe the surface of Mars would look like, what the atmosphere might consist of, and who might be living there. In 1976, many of these theories were answered when the Viking landers first touched down on the Martian surface. These landers found a very cold, desolate planet with no visible signs of life and a very thin atmosphere. Since then, NASA scientists have learned much more about the Red Planet. In fact, the United States has sent satellites to orbit the planet and small unmanned rovers to explore its surface. But with all that we've learned about Mars, unanswered questions still remain, such as, does life exist there? And has water ever flowed over its surface? Even though our satellites and rovers have provided a wealth of knowledge about Mars, limitations on their technology still remain. Satellites can only view the Martian surface down to about 1 kilometer, while the rovers can only travel a short distance from their landers. But a new type of rover being developed by NASA might soon provide us with a much better understanding of the Martian surface. Called the Mars Tumbleweed, this new rover is powered by the wind and has the potential to span a great distance over the surface of Mars, picking up scientific information as it goes. I spoke with Jeff Antal at NASA Langley Research Center to get a better understanding of how this new rover might work.
The Mars Tumbleweed is a concept for a new type of rover for exploring the surface of Mars. The conventional rovers use wheels driven by motors in order to move across the surface of Mars. The Tumbleweed would use the natural resource of the wind in order to be moved across the surface of Mars. It would be relatively inexpensive compared to the existing rovers and landers. However, that's fine because the Mars Tumbleweed is not meant to replace the existing rovers, but rather to complement the existing rovers. Conceivably, if they are less expensive, you could launch a large number of them, deploy them into a region, and have broader coverage of a region rather than just sending one rover.
How did you come up with this idea?
Well, the idea for using the wind to propel rovers across Mars has been around for some time, I believe since the early 70s. In 1997, Greg Hajos, the other principal investigator on the Mars Tumbleweed activity, he and I were discussing the Mars Pathfinder mission, and Pathfinder used an inflatable airbag system in order to land on the surface of Mars. So we were talking about how the airbag system and Pathfinder must have bounced and rolled a considerable distance before coming to a stop. and then deflating the airbags and the Sojourner rover deploying and only traveling a few meters. So we thought, would it be possible to continue the rolling as the airbag system was doing? Could you travel greater distances using that method rather than just a smaller rover? And would it be possible to use the winds to do that, much like a tumbleweed plant does here on Earth? A great analogy to this is comparison between a powerboat and a sailboat here on Earth, where a motorboat is limited in the distance it can travel by the amount of fuel it can carry. A traditional rover is limited by the battery and its power source. The tumbleweed is similar to a sailboat in that it uses the natural resources of the wind and therefore can travel greater distances and perhaps travel to greater areas on Mars.
Once on the ground, the tumbleweed will be able to start collecting data almost immediately. As the wind begins to blow, the tumbleweed will move across the Martian surface, traversing many miles in a short period of time. Once the wind stops blowing, the tumbleweed will stop and activate its scientific instruments, such as water-seeking radar, cameras, and other instruments that will search for signs of possible life. Once the wind begins to blow again, the rover will tumble to another location. As long as the wind continues to blow, the rover will be able to continue its journey across Mars. However, using the winds on Mars to move a rover is not a minor task. Because the Martian atmosphere is very thin, even the strongest winds would feel just like a gentle breeze here on Earth. Can you describe the various tumbleweed rover concepts?
There are two basic types of tumbleweeds that are currently being investigated. Inflatable beach ball type tumbleweeds are being examined by the Jet Propulsion Laboratory. We at NASA Langley Research Center are looking at non-inflatable tumbleweeds.
Both types of rovers would be about 25 feet in diameter, or about 2 stories high, but their designs would be somewhat different. The inflatable rover would look much like a beach ball made of a very tough, tear-resistant material. Of the proposed non-inflatable rovers, the shapes vary from a dandelion shape with foot pads to a box kite shape rover with sails. All of these designs would be lightweight and durable, allowing them to be easily driven by the Martian wind. Researchers here on Earth must now decide which shape would be the best platform for scientific instruments. Can you describe what type of science will be conducted by the rover?
There's a number of areas of science that we're currently investigating, anything from monitoring the weather to doing geological investigations to even searching for water or life on Mars. In order to monitor the weather, we may have it carry a number of pressure or temperature type sensors. Searching for life, you'd have some monitors for detecting water. Perhaps you could drop off sensors as the tumbleweed rolls in order to study the surface or to study the soil composition.
So, will the rover be controlled from Earth, or will you just let it go wherever the wind pushes it?
Actually, the initial concept for the tumbleweed, the first generation tumbleweed, would be entirely at the mercy of the winds. So it would go just wherever the winds push it. However, we've discussed a number of concepts for being able to add some control capability to the tumbleweed so that you could either stop it at a particular location of interest and start it again, or perhaps steer it in a particular direction and to go to particular areas that might be of interest. But even with the passive tumbleweed, you would have some starting and stopping depending upon when the winds are blowing and when they're not blowing. If the passive tumbleweed would even get blown into a canyon or a ravine and get stuck there, hopefully the sensors would still be operational and you'd still be able to communicate that data back to Earth, so you'd still have a functioning station.
What do you hope that NASA can learn from this rover?
We're hoping that the Mars tumbleweed will provide a new capability to go to regions on Mars that perhaps are not accessible by current types of vehicles, as I said, within canyons and craters and such. We hope that we'll be able to provide this capability at a lower cost and to provide, conceivably, a number of these could be sent at one time, covering broad areas and traveling longer distances than traditional rovers. And so these would act as scouts for other follow-on missions, perhaps more advanced landers or even human explorers.
NASA is not the only agency sending spacecraft to Mars. The European, Japanese, and Russian space agencies have all sent spacecraft there in recent years, with mixed results. Coming up, we'll discover how a new robot developed at NASA will assist astronauts in space. But first, did you know that Mars resembles Earth more than any other planet in our solar system? Due to the tilt of the planets, both Mars and Earth have 4 distinct seasons. However, this is where the similarities end. The Martian atmosphere is unsuitable for humans, containing about 95% carbon dioxide and no oxygen, with ground temperatures on Mars reaching as low as minus 193 degrees below zero.
Since the mid-1970s, manned space travel has been relegated to relatively short flights close to Earth's orbit. But with the push for manned travel to Mars and back to the Moon, researchers will need to make improvements in the development of systems and technologies related to spaceflight. With these new developments, the job of an astronaut will become much more complex. In addition to the necessary tasks astronauts need to perform on a daily basis, there will be a much greater learning curve to accomplish all the mission's goals. With this problem in mind, researchers at NASA have developed a new type of robot called the Personal Satellite Assistant, or PSA. This robot will help astronauts perform their tasks while freeing up precious time for other activities. Jennifer Pulley traveled to NASA Ames Research Center to find out more.
An astronaut's job can be incredibly demanding. In most cases, it takes years of specialized training to learn all the skills that will be used aboard the shuttle or on the International Space Station. So with all that an astronaut must learn and accomplish to get to space, it's not surprising that only the best and brightest are chosen to fly. In addition to the specific jobs astronauts are trained to perform, there are also many more mundane yet still important tasks that must be completed every day. Some of these tasks include monitoring environmental conditions in a spacecraft, such as the amount of oxygen, carbon dioxide, and other gases in the air, or just running routine checks on systems. Because these tasks must be performed every day, valuable time is lost trying to accomplish more of the mission's goals. With this problem in mind, researchers at NASA are developing a new device that could give astronauts additional time to complete mission goals. The Personal Satellite Assistant, or PSA, is a robot that could soon be helping astronauts by performing some of their more mundane tasks, thereby increasing crew productivity. I spoke with Dan Andrews at the NASA Ames Research Center to find out how the PSA works and how it will benefit astronauts.
The PSA stands for the Personal Satellite Assistant, and it's a type of robot that is intelligent and a free flyer to go aboard the ISS, a shuttle, or any spacecraft at all. It will fly around and it will be helping the astronaut on a number of easy or complex tasks. It can simply be a video recorder that records what he's doing. It could be a PDA that allows him to see what his tasks are for the day. The PSA can provide crew support as well as help to decrease system risk on a mission. The way it decreases system risk is to work with the environmental control system aboard the station or the spacecraft in general and help to diagnose faults and even rectify them. An astronaut will frequently be occupied doing some activity that will prevent him from being able to physically interact with a laptop or a PSA. And so the PSA is equipped with voice recognition software. The software will be able to understand the spoken words of the astronaut, convert them into text, and then enact what he is requesting of the PSA. For example, he can tell the PSA, please go down to rack 19 and check the temperature over there, because perhaps a sensor is indicating that it's getting hot over there. Maybe something's going wrong. The PSA would then parse that command into individual words, understand it, process it, go head out to that hot rack, and then take a temperature measurement, and then report back, also in spoken word by way of voice synthesis software, what it discovered.
How does this device propel itself or move around the station?
Most spacecraft or satellites propel themselves by using compressed gas that is stored within the body of the vehicle. In the case of the PSA, because it is operating inside of the station, in and around crew members, we thought it would be better to use fans or blowers as the propulsion means. In our first propulsion testbed, we used axial fans for what we're attempting to do. However, in the long run, axial fans do not work very well. This propulsion system has evolved from the propulsion system of its predecessor. This one employs a blower-based system. Instead of a series of 6 fan units, which the previous PSA uses, this uses 2 blowers, one located on top and one located on bottom. What they do is inhale air through these vents on the sides, 4 sides over here, and then exhale the air in a controlled fashion in order to get the PSA to move in and out, up and down, even perform rotational movements.
In addition to its assistance to the crew on board, controllers on the ground will also be able to command the PSA remotely, being able to monitor onboard systems while not bothering the crew. Another key benefit of the design would be the ability to have several PSAs conduct collaborative environmental troubleshooting activities. In order to accomplish this, several PSAs would use formation flying techniques